Good evening, everyone. How are you all? Okay, so we are starting off 7 minutes late, but still there are a lot of people in the class who have not joined yet. But today we won't be waiting for everybody. Okay, so that everybody joins in on time next time. Okay. So before starting up, can you guys please confirm in chat that my voice is clearly audible and that you can see my screen as well? Yes, voice is little low. Okay. Uh, I guess it should sound better now. Yeah, great, great, great. Ready to begin, everyone? Okay. Can anyone of you just put it down in the chat what we have discussed so far in the class? What was the last thing that we were discussing yesterday in the class? Can anyone of you please do that? Data types. Okay, great. Everybody revised everything that we discussed yesterday in the class? Okay. Okay, great. So let's jump into the next part. But before getting started, there are 2, 3 people in the chat section who are asking me to suggest a computer which is good enough to go on with this course, right? So I'm just going to give it a brief for that. Okay, so you can go ahead with an Intel chip. Okay, go ahead with Intel i5 and make sure the processor that you are, whatever the processor that you are choosing, it should have an H at the end. The processor name should have an H at the end. So let's say if it's a 12th generation, it should have something like this and an H at the end. Okay, make sure it has an H at the end. Okay, and for RAM, I think 8 GBs would be enough. And for storage, SSD or maybe SSD, please make sure that you choose an SSD for storage because that's a lot faster. And for this one, 250 GB would be more than enough. Okay, so this is the basic configuration that will give you a good, you know, i3 is also fine. i3 is also fine. If you have i3, then it is also fine. But if you're going forward, if you want to purchase a new one, then this is the best thing. Okay, and you can choose any company. And if you have Ryzen, if you're choosing AMD as your chip provider, then you can go ahead for a Ryzen 5. Okay, again, it should have an H at the end, XXH and H at the end. The processor name, the model number of the processor, it should have an H at the end. Okay, if you already have a system which has a Ryzen 3 or i3, or maybe you have a MacBook which M1 chip or M2 chip, it's all fine. It's completely fine. You do not need to buy a new one. It's just a recommendation if you are looking out to buy a new one. Okay. Yeah, Ryzen 5 7000 series is good. Yes, I3, 12, 15U is fine. Okay. Okay, let's move forward, everyone. Okay, just give me a second. Yeah, I7, 6 is also good. Okay, people. So we have seen a lot of things yesterday in the class, right? We have seen how computers operate. We have seen how programming languages came into existence, how computers understand us, what language is it that actually computers understand, which is, binary language. And we also know that everything that we tell the computer or everything that we code or every instruction that we give to the computer is actually converted into binary language, right? So it is converted into zeros and ones, and that is something that is understood by the computer, and computers then executes that, right? Yes or no? And then we also saw another concept of variables, okay, which was very similar to the algebra that we have studied in our sixth standard in our school, right? Yes or no? And it also we have also seen the concept of data types, because different types of values are given to the computer in the form of data or information. And for computer to understand what type of data it is, we have data types with us. And we also know that not all programming languages use data types. There are certain languages that are out there which do not require for you to specify data types explicitly. They understand it by themselves. They have their own mechanism of understanding it. Okay. Yes. So this is all that we have done so far. Okay. So today, people, we are going to take a new topic. Okay. Today, people, what we are going to do, we are going to take a new topic, and this topic is called operators. Okay. So let me take you guys back again to algebra, and just, if you can just remember, we saw something like this: z equals to x plus y. So if I take this thing and if I write it over here, x plus y, okay, so here something is happening, right? Here addition is happening. Yes or no? So an operation is being carried out over here by x and y and this plus operator. Okay, so what operation is going on over here? The operation that is being carried out over here is called addition. And this one is the operator. So this is operation. Addition is the operation. Okay. And this plus thing, this plus is the operator. And these two things, x and y, these two things which are involved in this operation, these things are called operands. Clear? So here an operation of addition is happening using this plus operator, and it is operating on these two operands, which is x and y. Understood? Okay, thank you for reminding me. I'll go slowly. Is this clear to everyone? X and Y is operand. Okay. Let me write it down once again. Maybe spelling is not that. Operands. Okay. Okay. Let me take it once again. Everyone, please pay attention. Okay. So here, what is happening is that over here, if you just pay attention over here, so here some operation is happening. Something is being done over here. Yes or no? So what is being done over here? This addition is being done over here. Addition is the arithmetic operation that we have studied in our sixth standard when we add two numbers, right? Can you recall it? Addition. We all know what addition is, right? So an operation is being carried out. Some task is being carried out over here, and that particular operation is addition operation. Okay, so this is what an operation is. Operation is a task which is being carried out is called an operation. Okay, in any particular line, in any particular part of the program, if there is some task being carried out, we call it as an operation. Okay. And this task is being carried out by the help of this operator over here, the plus operator. So this one is called the operator. It tells us the computer now you need to which operation. So operator is a symbol that helps computer understand which operation they need to carry out. Operator is a symbol that helps computers understand what operations they need to carry out. Understood? Done? Okay. And these two things, this X and this Y, these two things which are being involved by this operator in order to complete this operation. Okay. These two things which are involved by this operator in order to complete this operation, these two things are called operands. So operator operates on operands to complete the operation. So operands, we can say that operands are the values or the variables that are involved in a certain operation. Yes, computer understands based on operator which operation they need to carry out. Done, everyone? Have you all noted it down as well? So we have seen three different things over here. Okay, we have seen three different things over here. The first one is called the operation, the task that is being carried out. Okay. And second one is the operator, which starts or which tells the computer which particular operation they need to perform, right? This is the symbol that signifies or tells the computer which particular operation they need to do. Okay. And these two things, operands, they are involved. They are the values that are involved in the operation. Okay. Got it? Clear to everyone? These three things. Shall I move forward? Again, okay, which part do you want me to repeat? Can you please let me know in the chat where exactly your doubt is? If you can just put it down in the chat, it will help me in explain the difference between operation and operator. Okay, operation is the task. Okay, this addition is a task, subtraction is a task, multiplication is a task that we carry out, right? Just give me a second, people. Okay, sorry about that, people. Okay, so where were we? Okay, operation, right? So Okay. What? Okay. So yeah, I was talking about operations. Okay. So this addition is an operation, subtraction is an operation, multiplication is an operation, division is an operation. All these things are operations. Okay. So this is the operation. Whenever we see this plus operator, we know how do we need to calculate the value now. Yes. Whenever we see the multiplication sign, we know what we need to do, how we need to perform the operation, right? This is exactly how we actually respond to these symbols, right? Yes or no? Okay, so the operation that we are performing is the multiplication, addition, subtraction, or this, but this symbol, this operator, this symbol is actually telling us what we need to do. Yes or no? So this is exactly the same thing that is happening with the computer. So computer knows how to do the operation, how to do the addition, multiplication, subtraction. It is already loaded in it. Okay, so whenever it encounters this symbol, okay, plus operator, this plus operator tells the computer now you need to do the addition. Just like it is telling us whenever we are encountering this plus symbol, we also do the same thing, right? Yes or no? Whenever we see the plus symbol, we automatically understand that we need to add these two values. Yes or no? So this is exactly the same thing that is happening over here with the computer as well. Okay, whenever computer encounters this plus operator or multiplication operator or division or subtraction or whatever operator that's there, it is going to perform that exact same operation. So this is the difference between the two things. Okay, understood? Difference between operation and operator. Great. Okay. So, okay, now I'm yesterday. Okay, so you want me to tell the agenda for today? Is that so? This is what you're asking in the chat? If you can just please mention in the chat. Yes. Okay, so agenda for the today is that we are going to look at the operators. There are a lot of operators that are there in programming languages. So today our focus will be on operators only. Okay, and the different types of operators that are there. This is what we are going to do today. Okay. I already told you here. I always write the name of the module that we are discussing, name of the topic that we are discussing. I always write that. Okay. So you can take it from here as well going forward. And if you really want me to tell the agenda at the starting of the class, you can just ask it right away, just like you did today. Okay. Okay. Understood, everyone? People, please don't raise hand. There are a couple of people who are again and again raising hand. Please don't raise hand. Instead of raising hand, you can put down it in the chat so that I can understand it. Okay. It helps you understand better. Okay. We can connect better because raising hand does not actually mean much. Okay. Thank you. Okay. So understood, everyone? All these three things. What exactly do you want me to explain? Uh, can you please be quick about it because I need to take it. Otherwise, Ryzen 5? Ryzen 5 is okay. Ryzen 5 is a CPU. Ryzen 5 is okay. Ryzen 5 is a CPU. Okay. Every computer has a CPU. CPU is the core, the brain of the computer. It is where all the operations that are happening. Okay. So this is what CPU is. It processes everything. CPU is the part of the computer that processes everything. And Ryzen 5 is that. Just like i5, i3, you must have heard i5, i3, right? So this is exactly the same thing. Ryzen 5 is also a CPU. Understood? Clear? So it's from another company actually. i5, i3, i7, these are from Intel, and Ryzen 5, Ryzen 3, all these things are from another company. And the name of that company is AMD. 150 GB is fair. Okay, you can work around with that as well. That's the recommendation. The one, the configuration that I have mentioned is an recommendation. Okay, AMD and Intel both are good actually. There is actually no comparison between them. It's actually a preference, whatever you choose. Yeah, all these processors are fine, whatever you are mentioning. If it has Ryzen in it, it's fine. If it has I in it, i3, i5 like that, I is also fine. And if you're using MacBook Air, this MacBook Pro, both of them are fine. Using M1 chip, M2 chip, or maybe Intel chip, whatever you have, all of them are fine. MacBooks, all are fine. Okay, it comes to Windows PCs sometimes because they have lower configuration, a lot lower configuration actually. Okay, so it comes for that, but for MacBook, every single MacBook is fine. You need not worry about that. Okay, so let's just move forward, people. We have discussed a lot on that. So let's just move forward. And I think everybody now knows what operation, operators, and operands are, right? Yes or no? Okay, so now let's just look at the classification, the types of operators that we have with us. There are a lot of types of operators that we have with us. Okay, so the type of operators, the classification itself is divided into two parts. The type of classification is also two. Type of classification. Okay, so there are two ways in which you can classify operators. So the first one is on the based of type of operation. What type of operation that is being carried out. So there is going to be one classification on which is going to be based on the type of operation, and the second classification is based on the number of operands. Okay, so there are two classifications. Okay, the first one is based on the type of operation, and the second one is based on the number of operands. So now what we are going to do is we are going to take one classification at a time, and I'll tell you which of these categories it is going to fall into. Understood? Clear, everyone? Okay, so let's just move forward, and let's just take the very first classification. The first one is the arithmetic operators. Okay, so just as the name suggests, these operators are going to help you in carrying out arithmetic operations. Do you all know what arithmetic operations are? The basic mathematical operations like multiplication, addition, subtraction, and division. Okay, so yes, these operators are plus, minus, multiplication, divide, and there is one more which is called modulo. Okay, this one is called modulo. Clear, everyone? Yeah, this one looks like percentage, but it's not percentage. I'll tell you how it is. It is actually going to be calculated. Okay, don't worry. But this one is called modulo. Okay, so we have plus, we have minus, we have multiplication, divide, and modulo. Understood? Okay, so let's take an example. Okay, example is where we have x which is equals to 10, and we have y which is equals to 5. Okay, let's say this is an assumed value. Okay, we are taking these two values. Okay, yes, there are only 5. Okay, so the example would be x plus y. This is going to be the addition, the plus operator. We have x minus y. We have x multiplied by y, we have x divided by y. Okay, and we have x modulo y. So what will be the result of this one, people? X plus y. Who can tell me in chat? X plus y. What will the result of this based on these two values? Absolutely correct. It's going to be 15. What will be the value for this one? X minus y. Come on, people, quickly. X minus y. Great. It's 5. And what about for the multiplication? Come on, everyone. 50. Great. And what about 5 x divided by y? Great, it's going to be 2. So now let's just see what is going to be for x modulo y. So before getting that, we need to understand how we actually solve this one, right? So for modulo, we actually divide the number. Just like for division, we divide the number. So let's say we have x, which is 5. Okay, so here if I am having x divided by y, so what I'm going to do is this is something like this. I'm going to do something like this, that 5, 10, I will write it like this on my notebook, and I'll put 2 over here. Here it will come 10, and 0 will come out as the remainder. And this 2, which is called quotient, this quotient is going to be given as the answer over here. Yes or no? This is what we do in case of division. Yes. In case of modulo, we do the exact same thing. We do the exact same thing, but we give this remainder. This remainder is given as the answer. So here, x modulo y is going to be 0. Understood by everyone? Yes or no? Yes? Not understood? Again, repeating myself. In x modulo y, again, we divide the number only. Okay, the operation that we are going to carry out is the division only. Okay, but the answer is the remainder. Always remainder is given as the answer in terms in case of modulo, but in case of division, quotient is given as the answer. This quotient is given as the answer. That is the only difference between the two things. Okay, clear? Please note it down, and then I will take one more example for division and modulo. For modulo, remainder is given as the answer. For division, quotient is given as the answer. Understood? This is what we are doing. This is what modulo is. In both the cases, in both division and divide and modulo, we are going to divide the number. Division is going to happen. But what is served as the answer, final result, is the different in both the cases. In case of division, quotient is given as the answer, and in case of modulo, remainder is given as the answer. Understood? Yes, this is the symbol that is used. Okay, this is not percentage. We call it modulo over here. In programming language, there is no percentage symbol. We have modulo symbol. Okay. Percentage is symbol is also is only for representation purposes. It is actually not an operator. If you can recall, percentage symbol is not an operator. It's just a representation. It is only used for a representation purpose. Got it? Have you all noted it? Okay, so let's just take one more example. So let's say there is this number 23, and we want to divide it by 7. Okay, what do we want? We want to divide this by 7. So what we are going to do is we are going to write it something like this, yes or no? And we are going to write 3 over here, then 21 will come, and then we'll have a remainder of 2. Then I'm going to print a decimal point, right? Remainder of 2, decimal point, 0 will come over here. I have 7 2s of 14. Then 6 will come again. A 0 will come over here, and then I have another number. I can go ahead with let's say 8, and it will give me 56, and this will give 4, and we can stop right here. So we can say that the result for this one is 3.28, something like this. Yes or no? This is what we can do for division in case of division. Yes or no? Okay, people. Okay, but let's say I want to do modulo for this one. Okay, let's say I want to do modulo for this one. So what is going to happen is that I'm going to again divide the number by 7. Okay, I'm going to write 3 over here, then 21 over here, then 2 is going to come. Now I'm not going to put a decimal point over here. Okay, we are not going to, in case of modulo, we don't put a decimal point, we just stop right here on the last division. Okay, and this 2, this remainder 2, the final remainder that you're getting, this is going to be given as the answer. So you'll get 2 over here. Understood? Yes or no? Is this understood by everyone? People, please don't raise hand. Please use chat so that I can understand what you are trying to say. Why not 4? Okay, 4. We will not get 4 because we have already started this, because we don't put the decimal point over here. In case of modulo, we don't put decimal point. Okay, we don't put decimal point in case of modulo. We stop right there. Whenever there is a need of decimal point, we stop right there and we just write the final remainder as the answer. That's why not 4. Okay, we are going to stop right here only. We are not going to just put a decimal point and we are not going to put a 0 over here and continue the division. We're just going to stop right here. Yes, the calculation is not complete, but the calculation is complete. Calculation is not complete because for division, but for modulo, the calculation is actually complete. Okay, for division, the calculation is not complete. You have to put a decimal point and then put the 0 and then divide again, then again 0, then divide again like that. For division, you have to do that. But for modulo, the calculation is actually complete. Got it? Yes, modulo, answer of modulo will be 2. Okay, so we got a question, which is a very good question. The question is, sir, what if divisor is bigger than dividend? Okay, so let's just say if you are supposed to divide 4 modulo 10, let's say this is what you need to find. Okay, let's say this is what you need to find. So what is going to happen is that I'm going to write 4 over here. I'm going to write 10 over here. And this, since this cannot be divided, I'll put 0 over here, 0, and 4 is the remainder. So 4 will be served as the modulo, result of the modulo. We got it? Not got it? Okay. So what is your confusion? Those who are saying no, can you put down your confusions in the chat so that I can attend to it better? Yeah. Come on, people. Waiting for your reward. Those who are having any confusion, people who are having any confusion, just put it down in the chat and I'll help you out with that. Meanwhile, others, you can just copy it down, whatever we have discussed so far, make your own notes. Okay, and let me know in the chat once you're done. Value of 0 is not possible. Actually, I'm not able to understand this statement. Can you please let me know? explain it a little bit. Can you please elaborate a little? Value of 0 is not possible. 0 also is a value, which is 0 actually. Okay, calculators actually do not have modulo in it. You will not find it over there because this is actually utilized a lot of times in creating logical decision making in programming. Okay, so you'll see this modulo operator being used by yourself while making decisions a lot of times. Okay, don't worry, we'll get to that. Okay, don't worry. So this modulo is actually not present on your calculators because we humans do not use it in our day-to-day life or calculations. And I am pretty sure that you guys must not have heard about modulo till today's class. Yes or no? So this is not something that we are supposed to use. This is something that is related to computer programming. Okay, this is an additional or special operator that has been created for us to actually leverage it in order to make decisions. Later on, you'll see that it is going to help you a lot in when it comes to creating the logics, and when it comes for you to help computer in making decisions. Okay, so this is not used by us. The modulo is not used by us humans. Okay, this is for computer programming specifically. Okay, so 0.4 can never become a quotient in case of modulo, because modulo says that you do not go and put decimal point over there. Okay, it stops you right there. Okay, it says that you should not put a decimal point. Whatever that you are getting is the remainder. Got it? Yes, negative values can also be used. Understood? Yes or no? Come on, people. Got it? Okay. Especially the people who are having confusion. I know others, you already understood it. People who have asked questions, I want them to reply in chat. Is it understood? Yeah. Great. 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 Okay. So these are all the arithmetic operators that are there. Okay. So this arithmetic operator comes under the category of what? Since it is based on the type of operation. Okay. So this is arithmetic operators. Okay, all of them are arithmetic operators. This is based on the type of operation. And one more thing, as you can see over here, people, everybody, please pay attention. As you can see, this plus operator involves two operands. Yes? Yes or no? This plus operator involves two operands. Yes or no? How many operators for this minus operator? How many operands for minus operator? Again, two. Absolutely correct. For multiplication, again, two. Yes. For division, again, two. For modulo, again, two. So all of them are requiring two operands to complete the operation. Yes or no? So there was one more classification which was based on the number of operands. Yes. There was one more classification which was based on the number of operands. And since all of them are requiring or needing two operands to complete the operation, so these operands are also going to come under the category of binary operators. So they are arithmetic operators as well as binary operators. Understood? So based on the type of operation, their type is arithmetic operators. Based on the number of operands involved, their type is binary operators. Understood? So binary operators are the operators which involve two operands to complete the operation. Understood, everyone? Binary operators are the operators which involve or which require two operands to complete the operation. Got it? So if I just go back to this classification chart, so I can put arithmetic operators over here. since it is based on the type of operation? Yes or no? And I can put binary operators over here since it is based on the number of operands. Yes or no? So we have actually seen two different types of operators. One is arithmetic, one is binary, and these belong to two different classification types. One is based on the type of operation, another one based on the number of operands. Okay, so we got one very good question. Okay, we got one very good question from one of the students, and the question is, what if we write A plus B plus C plus D? Now it has four operands with it, right? Right? Yes or no? But what you're going to do is you are going to first add these two and you are going to get result 1. Then you are going to add this result 1 with C. You are going to get result 2. And then you are going to add this result 2 with D. And then you are going to get result 3. So this is the final result. But at a time, you are only adding two values. Either it is A plus B or R1 plus C or R2 plus D. You are only adding two values at a time. Okay, so in order to complete this operation, this entire thing, you only need these two operands, not more than that. Once you get the result of this one, then this is going to be added to this one and you will get another value. So actually what is happening here over here is that you, in order to complete one small part, entire operation, you only need two operands. That's it. Addition cannot happen with only one value. Can it happen? Yes or no? Can it happen? Addition. Can addition be done with only one value? No, you will always need two operands. Right? So this is what it is. So at a time, three operators is not possible in case of arithmetic operators. Okay. At a time, three operands is not possible in case of arithmetic operators, because that's not how they perform. That's not how they are operated. They function. Okay. For any arithmetic operators, only two values are required. Once you get the value or result of these two values, then you can use that result to do another operation. Got it? Done, everyone? Yes or no? Not understood. Binary operators. Okay, so binary operators are the operators which require two operands to complete the operation. So this is the definition. So as you can just pay attention over here on the screen, you have x plus y. So this plus operator over here, it actually needs this x and y, two operands to complete the operation and give 15 as the answer. Similarly, for subtraction, we have two operands to complete the operation and give the answer. Two operands for multiplication as well to give the result. For division, again two operands to give the result. And for modulo also, there are two operands required in order to give the result. Understood? So this is what binary operator is. So binary operators, so we'll see which one is not a binary operator. Okay, just be patient with me. Okay, so we'll see. There are other operators as well based on the number of operands involved. Okay, we'll see in a couple of minutes. But for now, I think everything is clear to everyone. Yes or no? So people, let's just take 1 minute of breather, everyone. Okay, meanwhile, you can just revise everything that we have discussed. Okay. And in case anybody has any confusion or want to ask anything, you can just go ahead and ask away in the chat. Okay, so there is a question. There is a question is what is the fundamental difference between binary and arithmetic operators? So as I just mentioned, these are two different types of classification. The first one is based on the type of operation. So this plus, subtraction, multiplication, division, they are all arithmetic operations because they are doing arithmetic operation, which is the basic mathematical operations like addition, subtraction, multiplication, and division and all. Okay, so this is based on the type of operation. Clear? Another classification is binary operators. This is because they need to, this is not what they are doing. This is based on how many operands that are required. So they require two operands. So that's why they are called binary operators. It does not matter what they are doing or how they function or how they operate or what is going to be the result of them. That is not what we are concerned about over here in this particular classification over here. What we are concerned about over here is how many operands are required. Yes, in arithmetic also there are two operands involved, but that is not what we are taking in consideration. In arithmetic, what we are taking in consideration is the operation, what they are doing. Okay, what they are doing, what type of value they are returning as a result, what type of operation that they are doing, the function, the operation that they are carrying out. That is what we are taking into consideration in case of arithmetic operator. So they are doing mathematical operations. Okay, they are doing mathematical operations, basic mathematical operations. That's why they are called arithmetic operators. Yes, all arithmetic operators are also binary operators. Absolutely correct. Done, everyone? I think 1 minute is also over. Shall we move forward? You'll see how binary are different from arithmetic. Okay, don't worry. Just give me a couple of minutes and you'll see the difference between the two. Okay. Okay, so let's jump back over here. So we have discussed the very first type, which is arithmetic operator. This classification is based on the type of operation that is being carried out. So second type based on the type of operation that is being carried out is assignment operator. So this is the next operator based on the type of operation. Okay, so let's see what they are supposed to do, what they are going to do. Okay, so I think you can recall this. Can you recall this? We have discussed this in the class yesterday, right? Can you recall this? X equals to 10. This means that this value 10 is going to be assigned to this variable X. Now this X variable has a value which is equals to 10. Yes or no? This is what is happening over here. Okay, so this equal to operator, this equals to operator, what it is doing is it is actually taking this value and it is assigning this value to this variable. So this equals to operator is the assignment operator. Understood? This equals to operator is this equal to operator is assignment operator. Understood? Because it is assigning a value to a variable. Is this clear to everyone? Yes or no? So here again, there are two operands involved. First one is X and second one is this value 10. There are two operands involved. So again, this will also come under the category of binary operators. Yes or no? So this equal to is not actually an arithmetic operator. It's an assignment operator based on the type of operation, but based on the number of operands involved, it's a binary operator. Understood? So now you can understand the difference between arithmetic and binary also. Those who were confused, yeah. Since there are two operands, x and y, this is operand number 1, this is operand number 2, two operands, so it is also a binary operator. Which part do you want me to repeat? Can you please mention that? Have you understood the work of assignment operator? No. Okay, let me just take it from the top. Okay, let me just take it from the top. Okay, people, so that nobody is confused. Okay, so we have x equals to 10. Okay, so here what is happening over here is that this value 10 is going to be assigned to this variable x. So here this equal to operator, what it is doing, it is assigning this value 10 to this variable x. Okay, so this equal to operator is called the assignment operator because it is doing the operation of assigning. Understood? Yes or no? So that's assignment operator. Done. Full stop. Okay. Now comes the second part. Okay. Second part is since this equals to operator requires two operands. Okay. The first one is x and the second operand is this value 10. Okay. With operand, I do not mean the variables. The operand can be variable or a value. It can be anything. It can also be an expression. Okay. Please try to understand. Please don't take operands as variables only. It can be anything. Okay. So this equal to operator requires two operands, which is x and this value 10. So since it is requiring two operands, it is called binary operator. So this equal to operator also comes under the category of binary operator. Understood? Yes or no? Come on, everyone, in the chat. Yeah. Anybody in the class who has any confusion with this one? No one? Anyone? Come on. Great. Great. So I guess now it is clear what binary operators. Binary operators are the operators which require two operands. Simple. There is nothing related to what they are doing, how they are doing, when they are doing, nothing related to that. We are not concerned with what they are doing. They're only concerned with how many operands that they want to complete the operation. So here this equal to operator again requires two operands to complete the entire operation. If I only give it x, is it going to do anything? If I only give this variable x to it, is it going to do anything? It won't be able to do anything. It won't be able to do anything. Why? Because it needs another value. Okay, so I got another question in the chat, which is actually good. Okay, so the question is if I write x equals to z equals to x plus y, now there are three operands involved. So the answer is no. So what is going to happen is this is going to give you a result r, and this r is going to be used by this equal to operator, this assignment operator, to assign this value to this z. So again, it is only using two operands. This is the first one and this is the second one. Two operands, that's it. Okay, no three operands, only two operands. Yes, R is assigned to Z. The result of X plus Y is actually assigned to Z. Got it? Okay, another question. Another question is X plus Y plus Z equals to 10. Okay, So here what is happening is that this equals to is actually forming an expression. Okay, this is for you only, for you humans to understand. This means that whenever you solve this, you are going to get 10. This is what is happening over here. You are confusing it with the algebra. Again, don't get it confused with the algebra. Okay. So this equals to over here. This tells you if you solve this thing, you are going to get 10. This is what it is telling you. This is not an assignment operator. Okay. This is just helping you out in forming the entire expression. This is a different thing. Got it? Is this clear to everyone? Yes or no? Okay, so there are a couple of other assignment operators as well, which are actually created with the help of this arithmetic operators, and we call them shorthand operators. Okay, we call them shorthand operators, but they are actually come under the category of assignment operators only. Okay, so let's just take a look at them. So we have, let's say x is, let's assume a value of x, let's say x is 10. Okay, let's say x is 10. So we have shorthand operator, which will look something like this: x plus equals to 5. So, okay, so this is a shorthand operator. Okay, so this is a shorthand operator, shorthand plus, we call it shorthand addition. So it is, what it is doing is it can be expanded something like this: x equals to x plus 5. So what happens is that you are going to use this value of x over here, 10. You'll do the addition between these two values. Okay, so you'll get 15. And this 15 is going to be assigned to this x. So x will now become 15. A new value will come into it. Okay, a new value is going to be assigned to it. Understood? Yes or no? Come on. Yes? I'm going to repeat it once again. Okay. So similarly for this one, x plus equals to 5, we have x minus equals to 5 as well. Okay. So this can also be expanded like x equals to x minus 5. So when I solve this one, instead of this x, I can use this initial value. Okay. I can use this initial value, which was 10. Okay. So this can be written as 10 minus 5, which will be equals to 5, and this value 5 is going to be assigned to x. So the new value of x will now become 5. Understood? Clear what a shorthand operator is? This is what a shorthand operator. Again, it is doing the job of assignment only. It is, but before assigning, it is also doing some arithmetic calculation. So that's why they are called shorthand assignment operators. Okay, this is addition assignment, this is subtraction assignment. Similarly, we have multiplication, a multiplication shorthand. Okay, so this will be x. Yeah, 10 is an assumed value over here. 10 is an assumed value. Yes, it can be anything. X can be anything. We're just assuming it to be 10. Okay. 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 Got it. So what will the answer for this one? X multiply equals to 5. Who can tell me? Yes, absolutely correct. This is going to be 50. The new value of x will be equals to 50. And if I take x divide equals to y, 5. Correct. The new value of x is going to be 2. And for x modulo equals to 5. Absolutely correct. X is equals to is going to be 0. Correct. Absolutely correct. Clear, everyone? Please note it down. Let me know in the chat once you're done. Quickly. Please don't get confused. Just ask it away, whatever you are getting confused at. Okay, so this becomes 0 because here we can expand this one. This can be expanded at x equals to x modulo 5. This x is actually 10 over here, right? So 10 modulo 5. it is going to result in 0. So this is the new value of x. Which part do you want me to repeat? Can you please mention? Yeah, there are a lot of programming languages that use shorthand operators actually. There are a lot of programming languages out there. X is one operator. Yes, absolutely correct. X is one operand, sorry. But we can expand it. This is for explanation purpose. This is how we can expand this thing. This expression can be expanded like this. Okay, this is for your understanding. This is for your understanding. But here, this is the actual thing. So this is operand number 1, and this is operand number 2. That's it. Yeah, everything is loaded in the LMS. If you just go through the content that is provided in your LMS, you'll get programming foundation notes or notes and recorded things, recorded videos over there. Okay, you'll get everything over there. Yes, in binary operations, 2 operands are required. Here is 1, x, here is second, 5. These are all also binary operands. Done? Anybody? Any other confusion? Okay, so this operator is actually a combination of 2 symbols. This does not mean there are 2 operands. No, this does not mean that there are 2 operators. This is a combination of 2 symbols. This operator is a combination of 2 symbols. This does not mean that there are 2 operators involved over here. Please make sure that you note this down. Okay, people? Yeah, I'm saying that this division and equals to this does not mean that there are 2 operands and operators involved. This operator is made or it is written by using 2 different symbols, which is divide and equals to. 2 symbols make one operator. So operator is not always one symbol only. It can be a combination of more than one symbols as well. Understood? So one example for this one would be, so let's say there is this x, which is equals to 10. So now I want to increase this value of x by 10. So what I am going to do is x plus equals to 10. So now x will become 20. This x is now going to become 20. Yes or no? If again I'm going to increase this value of x by 10, what I can do is again I can write it like this, and now this x will now become 30. Got it? So this is one use case where you are going to use shorthand operators. X plus equals to 5 is equals to 15. Yes, absolutely correct. Have I written anything else? Yeah, no, I haven't written anything else. If you can just look it over here, I've written 15. Is this example clear to everyone? This is one use case for shorthand operators. Not clear? Okay. So let's say you want to print, let's just take, you want to print numbers from 10, numbers like 10, 20, 30, 40. So what you're going to do is, you're first going to do it x equals to 10, then you're going to print this value. Now you're going to change this value of x plus equals to 10. And now this will become 20. Then again, you're going to print x. So 20 will be printed. Okay, something like this is going to happen. Then again, you are going to do x plus equals to 10. So now x will become 30 and now 30 will be printed. Okay, and like this you can go on. Okay, just an idea. I'm just giving you guys an idea. Got it? One use case of it. So if I want to increment the value of the variable, I do not want to involve any other variable. I just want to increase the value of my existing variable. So this shorthand operator can help me with that, right? Similarly, it can help me with decreasing the value or multiplying it or dividing it, getting a modulo out of it. Yeah. Understood by everyone? Arithmetic operators. Yes, square and cube are not basic operators. They are actually an advanced operator that has been that can be that is actually a result of multiplication only. Okay, so we are only discussing the basic operators over here. Done, everyone? Shall we move to the next one? Great. Okay, so we now also know that these shorthand operators are also binary because they need two operands. Yes. Okay, so let's just come. So can I just go back to my chart and can I put assignment operators here? Yes or no? Got it. So again, type of operation, assignment. So I put assignment operators over here. And we haven't seen anything new over here. So nothing for the number of operands classification. Okay. So let's go ahead. This was the second type. Let's go to the third one. So third one is comparison operator. So as the name suggests, these operators are going to help us in making comparisons. Okay, so let's take an example. Okay, let's just assume that X is actually 10 and Y is actually 5. Okay, we are just comparing, going to compare these two values now. Okay, so what is going to happen is the very first comparison operator that we have with us is greater than. Okay, then we have less than. Then we have greater than equals to. Then we have less than, sorry, this is not greater than equals to. Actually, I'm saying it otherwise. Okay, so this one is greater than. This one is less than. Then we have greater than or equals to. Then we have less than or equals to. Then we have equals to, whether two values are equals to each other or not, equals to. And then we have not equals to. In some programming languages, it is given like this as also. This not equals to also given like this also. Okay. Okay, so let's just say we have X and Y. So again, X greater than Y. Okay, something like this. It is also going to be using two operands. This one is also going to use two operands once again, two operands once again, two operands once again. Okay, so the thing with comparison operators is that they always work or they always result in either true or false. They always give Boolean result. Okay, either they are going to result in true or they are going to result in false. Got it? Yes or no? So if I take an example of this one, x greater than y. So in our case, where x is 10 and y is 5, is this going to be true or false? Come on, everyone in chat. True or false? Yes, absolutely correct. This is going to be true. What about x less than y? Is this going to be true or false? False, absolutely correct. And let's go for the third one, which is x greater than or equals to y. Is this going to be true or false? Absolutely correct. This one is also going to be true. Why? Because it is including two conditions, both of them. We have or over here. Either this is true or this is true. If any one of the true, then this is going to be true. Okay, we have or over here. Okay, if it is greater, then also true. If it is equal, then also it is true. Okay, got it? So similarly, this one less than equals to x less than equals to, it is true or false? Come on, everyone. This one is false. Absolutely correct. Then we have x equals to y. Is this true or false? Whether the two values are equal to each other or not. True or false? False. X not equals to y. Is this one true or false? True. Absolutely correct. Okay. So these are the comparison operators, 6 comparison operators that we have with us. Got it? Again, all of these comparison operators are also requiring two operands. So they also come under the category of binary operators. All of them come under the category of binary operators as well. Clear? Is this understood by everyone? Yes. Please note it down. Let me know in the chat once you're done. Quickly. Which part do you want me to repeat? Third one. Okay. So here what we are doing is we are actually considering both the conditions. If the number first one is greater than, if x is greater than y, then also it is going to be true. Or we have or, not and. We don't have and over here. We have or over here. Logical and on or, if you can remember from your 9th standard, 9th grade. Okay. So if this one is true, then also it is true. If this equals to is true, then also it is going to be true. But if both the conditions are not satisfied, then it is going to be false. Just for this, just like for this case, less than equals to. Here, less than is also not true and equals to is also not true. So this one is going to be false. Got it? Good. Please note it down quickly. Also repeat fourth one. Fourth one is the same, right? Just like that one, less than or equals to. So this x is actually not less than y, and it is also not equals to y. So both conditions are getting false. This is also false and this is also false. Since both the conditions are false, so this entire thing also gets false. Got it? Third one I just explained. Okay. So greater than, there are two conditions. This is first one. This is second one. If this one is true, and this one is false. If any one of this is true, then it is going to be true. This entire thing is going to be true. Got it? Because we have or over here. But if both the things are false, then it is going to be false. If both the things are true, then also it is going to be true, which is not going to be the case anyway. Sixth one is not equals to. So this tells whether both the values are not equals to each other or not. So this x and y, as you can see over here, x is 10, y is 5. Both of them are not equals to each other. That's why it is going to result in true. Got it? Understood, everyone? Done? Why we write not equals to in such a way? Okay, so that's how it is defined by the computer scientists while creating the programming languages, I can say. Okay, simple. There's nothing special about it actually. That's how you write it. In some programming languages, you will see that not equals to is written in this way, like X not equals to Y, something like this. Okay, in some programming language, you are going to see that it is written like this. So yeah, got it, everyone? Great. So let's move forward to the fourth one. So fourth one is logical operators, just like logical gates, if you can remember from your ninth grade. Can you guys remember them? And gate, or gate, not gate, XOR gate, like that. Can you guys recall them? Logical gates? I don't want you to remember everything about them, just an idea. Yeah, that is something that was there, right? So we have three basic logical operators with us. The first one is AND, second one is OR, and the third one is NOT. Every other thing is going to be the combination of these three only. Okay, so this AND is given by ampersand symbols, twice ampersand symbol. This is called ampersand. This symbol is called ampersand. Okay, this one is given by twice pipe. So this symbol is called pipe. And this one is called, this one is the not operator, which is called exclamation. I think everybody knows what exclamation is, right? So I guess you can locate this on your keyboard, and you can locate this also on your keyboard. So this pipe symbol is actually present on your keyboard around the enter key. So let me just show it to you guys. Just give me a second, how you can actually look out for that. Okay. Okay, so we got a keyboard that looks something like this for Windows devices. Can you guys see this keyboard? So here is the pipe symbol. If you can just see, this is the key that you're looking for, this one. So this upper one is the pipe. Can you guys find it? If you can find it, just put it down in the chat. And for Mac users, let me show it for you people as well. Mac. Let me just show it to you. Oh, got it. So the Mac keyboard looks something like this. And I think you can find the pipe. This is the pipe over here. Can you Mac people also find pipe? I cannot see it with the people in the chat. If you can see the pipe, if you have found it, just put it down in the chat. Put the pipe symbol, the or operator in the chat. I want all of you to type or operator in the chat. Use shift. Don't write yes, don't write found. Just type the key. Type the operator in it. Yeah, people are pressing backslash. You need to use shift key as well. Use shift key as well, everybody. This is not exclamation sign. No. This is not exclamation sign. This is pipe. Exclamation is over here. This is exclamation over here. I'm not talking about this one. I'm talking about pipe, which is over here. Come on. I've shown for both. I'm not getting response from everybody. Great. I think now everybody found it, right? So this is what OR operator looks like. Understood? This is AND operator, this is OR operator, and this is NOT operator. Got it? So we have some truth tables associated with these logical operators. So what happens is that these logical operators, they operate on only Boolean values. They only operate on Boolean values. Okay, they don't result, they also result in Boolean values, but they always operate on Boolean values. Got it? So if I want to write or if I want to understand the operation of AND operator, so it can be given by a truth table which looks something like this. So let's say I have a variable X and I have a variable Y, and I want to figure out what X and Y is going to look like. So if X is false and Y is also false, if both the values are false, okay, if both the values are false, then this is also going to be false. X and Y is also going to be false. And let's say if any one of the value is true, anyone, then in that case also, this is going to be false. Got it? But if both the values are true, X is true and Y is also true. If both the values are true, in such a case, X and Y is going to be true. This is the only case when X and Y is going to be true. Otherwise, it is always going to be false. Is this clear to everyone? So that's how it is given, the truth table of X and Y. I think you can recall it as well. You have already studied this. We are just revising actually. Can you guys recall it? Yeah, it is also there in Excel. Yeah, you have already studied Excel, so it's there also. Okay, so we have the next that we have with us is OR operator. Yes, it's on digital electronics. Yes, absolutely correct. Then we have next is we have OR operator. So we have X, we have Y. So what will be X or Y? So if both the values are false, in case both the values are false, the X or Y is going to be false. Clear? In case any one of the values is true, whether it is Y or whether it is X, if any one of the values is true, then X or Y is also going to be true. So for X or Y to be true, any one should be true. Okay. And if both the values are true, then also it is going to be true. So X or Y becomes false only and only if both the condition, if both the parts, both the operands are false. Got it? So this is the truth table for X or Y. Understood by everyone? Please note it down. Done? Next one is not operator. So we have X and we have not X. Not X is given like this. Okay. So let's say if X is false, then not X will become true. So what does it do? It changes the value. If it is false, it will be changed to true. If it is it is true, it will be changed to false. It just reciprocates the value. Okay, swaps the value. So if X is false, not X will be true. And if X is true, and then not X will be become false. Understood? Clear, everyone? So this is the truth table of not operator. Understood? Yes or no? Come on, people. Please note it down. Let me know in the chat once you're done. So these are all the logical operators that we have with us. Yes, it inverts the value. Absolutely correct. So as you can just pay attention over here, this one involves two operands, X and Y. So this one is binary. Okay. This one again involves two operands. This one is also binary. But this not operator, it only involves one operand. Can you see? It only involves one operand to complete the entire operation. So this one is not binary. This is another categorization. This is another type based on the number of operands involved. And this one is called unary operators. Unary operators are the operators which require only one operand to complete the operation. One operand, so unary. Understood by everyone? What unary operators are? You can note down all the truth tables. Let me know in the chat once you're done. Unary not clear? So unary operators, just like binary, unary operators are the operators which involve only one operand to complete the entire operation. Understood? Understood, everyone? Yes or no? Okay. So if I go back to the chart that we were making, so we have discussed a couple of more types. So here we have comparison, which will come over here. Okay. And here we have logical operators, which will come over here. And here we have also found out one more new, which is called unary operator. Got it? So these are the operators that we have discussed so far. Done, everyone? Please take 1 minute breather, everyone, and just revise everything that we have discussed so far. If you want to drink some water and all, just relax a little bit, and then we'll move forward with the next topic. Okay? Cool. Meanwhile, if you have any questions, you can just put it down in the chat. I will help you out. Not symbol is this exclamation. This exclamation is the not symbol. Okay? Not just this. This is not the not symbol. For not, we have this. People, please don't raise hand. Instead of raising hand, please put it down in the chat. You have a doubt in or symbol. Okay, what is your doubt? Can you help me with your doubt? You didn't get it? The not symbol? You're actually using it in the chat. The pipe symbol is the not symbol. The pipe symbol is the or symbol. You have to use it twice. Unary operators are the operators that require only one operand to complete the operations. There is no why behind them. Okay. Why they are used, what they are used for, nothing. It's just based on the number of operands that are involved. This classification is only based on the number of operands that are involved in completing the operation. Got it? Understood, people? The one who asked the question, is this clear to you? No, this is not the or symbol. This is actually the bracket, closing bracket. Okay, this is not the or symbol. You want me to send it in the chat box? Okay, let me just show it to you in the image over here. What system you are using? This one is for Mac, the below one. This one is for Windows. And this one is for Mac. Okay, so here is the pipe symbol for Windows people. Okay, the upper one, this one. So it is like this. This is the key. You have this pipe and you have this backward slash. So this is what you're looking for. Okay. If you want me to put it down in the chat, let me just put down in the chat. This is the symbol. It might be visible to you like this. It might be visible to you like this. Okay, sometimes it is given like this, or sometimes it is given like this, one single line, but it's 5. Okay, got it? Sometimes in your keyboard, you can find it at broken like this. You want me to send not symbol? For not, we have exclamation, which looks something like this. Ampersand is the and symbol here, right above 7 over here. This is ampersand. You also call it and. Done, everyone? Are you all relaxed? Can we move forward? Where is not? Okay, so not is over here, right above the 1. This exclamation symbol. Can you find this exclamation symbol over here? And also over here in Windows, right above 1. So here is not. This is not. Exclamation. Yes, absolutely correct. Yes, you have to write double pipe for or. Yes. Anyone else? Any questions from anybody else? What is the use of pipe? Okay. What is the use of pipe? Pipe in programming languages, this is for or. Okay. If you use single pipe, that's a different or. And if you use double pipe, then that one is logical or. Okay. Single pipe is called bitwise or. That's a different operator, which is not this, which is something that we as a data scientists are not like needed to know for us. Okay, so that's something that we don't need to know. So that's for computer people, computer science people, developers. Okay, but for us, we just need to understand logical or. So for that, we need to use double pipe, and we now know what double pipe is used for, right? You have seen the truth table. Done, everyone? Any questions from anybody else? Great. Okay. So people, let's just move forward. Okay, so we got one more question. I have a question. Let's just assume A is 25. Okay. So people, here is a question from one of the students. Let me just copy it out. So it looks something like this. Okay, so I have a question. Just assume that A is 25. Okay, so let's just assume A is 25. So this statement is true. Okay, so we have A greater than equals to 10. Okay, so A is 25. So 25 greater than equals to 10. So yes, this is true. 25 is greater than equals to 10. So it's true. Okay, this is always going to result in true. And next one is A less than equals to 20. Okay, A less than equals to 20. So here we have 25 less than equals to 20. So this one is going to be false. This one is going to result in false. Got it? And this is supposed to be small a over here. This is supposed to be small a. I guess I should use a darker pen over here. So this should be smaller because you're using small a over here. So computers usually treat capital letters and small letters differently. Programming languages do that. Okay. So for them, small a is different and capital A is different. Understood? So always make sure that you don't get these mixed up. It's usually the case. Yeah. Not with all programming languages, but I guess more than 95% of the languages, for them, small a and capital A, small letters and capital letters are different from each other. They treat them differently. Understood? Okay, so let's move forward. So the sixth, actually, this is sixth, right? Or fifth, I guess. Fifth, okay, fifth. So this is the fifth type, and this one is called conditional operator. This actually helps you in defining a condition, and based on that, you can do something. Conditional operator. So what does it do? Let's just see. So what does it do? So the syntax for this one, how you are supposed to write it. So you are supposed to write it something like this. So you are supposed to define a condition. Okay, this is always going to result in either true or false. This should always result in either true or false. So there has to be a condition which will always result in either true or false. And then you're going to put down a question mark. So this is the part of conditional operator. Okay, and then you are going to have statement one. Okay, so this statement one is executed when this condition is true. When this condition, yes, this is similar to if and else. Right, absolutely correct. And if this condition is false, then we need to put this colon. This is again also part of conditional operator. So conditional operator is actually combined with combination of these two symbols. Okay, so here we have another statement. We need to have another statement, which is statement number two. So this statement number two is supposed to be executed when this condition becomes false. Got it? So when this condition becomes false, then this statement is going to be executed. So this is how this operator is going to be written. Okay. So this operator is actually a combination of two operands, two symbols. This operator is actually a combination of two operands, as you can see over here. And it requires three operands. The first one is this condition. This is operand number one. Then this operand, this is statement number two, which is operand number two. And this statement number two, statement number one is operand number two, and this statement number two is operand number three. So it requires how many operands, people? Three operands. Yes? Clear to everyone? Yes or no? Okay, so let's take an example for this one. You want me to repeat? Okay, what exactly do you want me to repeat? Which part? Where exactly you're confused? So these are the two symbols. Okay, these are the two symbols that are involved in conditional operator, and these are the three operands that are involved in conditional operator. So conditional operator says, in order to complete this operation, what you need to do is you need to have a condition which is always supposed to result in either true or false. Okay, you need to have a condition which is always going to result in either true or false. Then you're going to have this question mark question mark symbol. Okay, and this question marks evaluate whether this condition is true or false. If this is true, then it is going to execute this statement number one. Got it? This question mark is going to do what? If this condition is true, it is going to execute statement number one. Okay, and if this condition is false, then it is going to execute statement number two. And this colon is doing what? Is actually separating these two statements, statement one and statement two. It is separating statement one from a statement two. Got it? So let's just take an example for this one, people. Okay, maybe that will clear it a little bit more. Okay, so here is an example. Everyone, please pay attention. So let's say I have x equals to 10 and y equals to 20. Okay, so I have x greater than y. So this is a condition. It is always going to result in either true or false. Yes or no? We know comparison operators, they always result in either true or false. Yes? So this is going to result in either true or false. So I'm going to put a question mark over here. And if this condition is true, I'm going to print something. So this is going to be statement number one. Print x is greater. Got it? So if this condition is true, I'm going to print x is greater because this means x is greater. And if this condition is false, then what I'm going to do is I'm going to print something else, and I'm going to print what? I'm going to print y is greater, because if this is false, then that means y is greater, right? So this is the entire conditional operator, one example of conditional operator. So what is happening over here? Everybody please pay attention. So what is happening over here? This thing is either going to result in true or false. So for our case, what is it going to result in? Who can tell me? Who can tell me? This is going to result in false. Absolutely correct. So this is going to result in false because y, which is 20, is actually greater. So this will be false. So statement 1 is going to be executed or statement 2? Who can tell me in chat? Since this condition is false, which statement is going to be executed? Absolutely correct. Statement 2 is going to be executed, and on the screen, on the output screen, my user will see this printed on the screen. So my user will see y is greater. This will be printed on the screen for the user. Got it? Understood? Please note it down. Let me know in the chat once you're done. Everybody. You want me to give one more example? Okay, I'll give you one more example. Okay, let me know once you're done. Okay, first note it down and let me know once you're done. Then I'll give you one more example for this one. Come on, everyone. Done, everyone? Okay, great. So let's take one more example. Let me give you one more example. So another example would be, so let's say x is 23. Okay, so let's say if I write this x modulo 2 double equals to 0. This is my condition. Okay, so I'm going to put a question mark over here. If this is true, then I'm going to print x is even. If this is false, then I'm going to print something else, and that would be x is odd. Okay, so let's see how this is going to function. So I have x equals to 23. So what I'm going to do over here, x modulo 23. I'll find x modulo 23. So it is going to result in 1. Yes or no? And then this comparison operator is going to be activated. It will compare this value 1 with 0. And it is going to result in what? True or false? True or false? Come on, everyone. Come on, people in chat. False. Absolutely correct. So this is going to result in false, which means this statement number 2 is going to be executed, and on the output screen, the user will see that x is odd is printed on the screen. Got it? And let's say if I change this value of 23 to, let's say, 40. In this case, the result of this condition will become what? This will become true. Yes or no? This will become true. Yes. So this time what will happen? This statement is going to be executed and the user will see x is even written on the screen. Got it? So this is another example for this one. I think it is clear to everyone, conditional operator. You want me to repeat? Okay, let me repeat it for the people who are not able to understand. So this is another example. In this example, what we are doing is we are actually checking whether the number is either even or odd. Okay, whether the number is even or odd. So we have taken this value where x is equals to 40. We have taken this value where x is equals to 40. Got it? So here what we are going to do is we are going to find the modulo of 40 with 2. So this is going to result in 40 modulo 2. This is going to result in what? It is going to be, what will be the remainder for this one? If I divide 40 by 2, come on. Those who have asked me to repeat it, I want them to be super active, hyperactive actually. Come on, the one who asked the question, can you please respond in chat? What will be the remainder of this one? Everybody else is responding. Why are you not responding? I want you to respond. Come on. Yeah, if you are not willing to respond, then please don't ask questions. Okay, this is not actually good. Because I'm trying to help you out. And you have to help me to help you out. Okay. So this is really important for us to communicate with each other. Okay. So if I divide this 40, okay, here it is. Okay, so you have written wrong answer. Okay, so why it is wrong? Let me tell you why. Okay, so when I divide 40 by 2, when I divide 40 by 2, sorry, 40 by 2, what I'm going to get is I divided by 2. This will give me 4. Then I have 0. I'll write 0 over here. And this 0 is going to be the remainder. So this 0 is served as the answer of the modulo, not 20. This is where the problem is. Okay. So that's why I wanted you to respond. Okay, please respond whenever I ask you to respond. It is very, very important. Okay, so this 40 modulo 2 is 0. So this 0 is actually equals to this 0. This 0 is actually equals to this 0. So this one is going to result in true. Got it? And since this is true, it is going to execute statement number 1, which is x, which is going to print x is even on the output screen. Got it? Yes or no? Is this understood? Okay, people. So whenever you ask a question, okay, it is a request from my side. Whenever you ask a question, you have to be super active, because if we don't interact with each other, how will I know whether you are understanding or not? Then again, in the end, you'll say, I don't understand. Please repeat one more time. Okay, so that just wastes time for both of us and as well as of the entire class. Okay, so whenever you ask a question, and if I ask you to respond to any of the question in the chat, you have to be super active. Don't worry whether it is wrong or right. Okay, because I'll correct you if you're wrong, and if you're right, then it's great, right? So we need to interact with each other. Okay, why double equals to is used here? They got one question from another student, and the question is why we are using double equals to, because we want to compare this result. This result is supposed to be compared with 0. So this is a comparison operator. So we are comparing the value, and based on this comparison operator is going to result in either true or false. And based on this result, we are going to either execute statement number 1 or statement number 2. Got it? Yes, this is something like else. You already know what else is from Excel, which Rohit sir taught you, right? Understood, everyone? The conditional operator, is conditional operator clear to everyone? Okay. So let me just pull the screen up a little bit. And we just discussed over here that this conditional operator involves 3 operands. Yes. So this is not binary, this is not unary, this is something new. And this new thing is called ternary operators. So ternary operators are the operators which require 3 operands to complete the operations. Understood? Yes or no? Clear, everyone? Please note it down. Ternary operators are the operators which require Three operands. Okay, I have written it wrong. This is not operator operands. This is operators. Okay, so now let's just go back to the chart that we were making. And here we are. So we have studied one more over here, which is conditional operator. Yes. And we have one more over here, which is ternary operator. Got it? So these are all the basic operators that we are supposed to. What is ternary operator? Ternary operators are the operators which require three operands to complete the operation. Okay. So based on the number of operands, there are only these three. Okay, based on the number of operands involved, there are only these three: unary, binary, and ternary. Okay, that's it. And based on the type of operation, the basic ones are these five. There are more, but these are the basic ones, and those others are actually created using these five only. Okay, and there are a couple of more which we as a data scientist don't require. We only need these five. Okay, so these are the five operators that these are the five operators that are there based on the type of operation that is being carried out. Got it? And there are three based on the number of operands that are involved. Understood? So this is all about operators, people. Understood, everyone? Yes. I hope everybody had noted everything down. Yes. Okay, so people, that will be all for today. We are not going to discuss anything else. We were supposed to discuss operators, and that is what we have done today. We have completed operators. And in the next class, we are going to discuss another new topic. For this week, I want every one of you to revise everything that we have discussed so far in the two classes, and also whatever you have discussed with Rohit sir in the Excel classes. Okay, so you have to discuss everything. Example of ternary operator I have already given. Conditional operator is an example of ternary operator. This one, if you can just recall, this is the only ternary operator that is there. Just one. Here. This one is the ternary operator. Ternary operator is this. Conditional operator, this one. This is ternary operator. This conditional operator, this one is the ternary operator. Yeah, you can leave. People who are done can leave. We are actually done for the day. Yeah. Good night, everyone. Bye-bye. Okay. Meanwhile, if there is anybody in the class, if you want to ask anything, you can just go ahead. I will help you out with that. Otherwise, we will be concluding this class now. Okay, people, bye bye, good night. Yeah, we won't be requiring to study bitwise operator. That's actually not required in data science actually. So that's why we won't be getting into that. Okay. In the next class, actually, we will be covering control structures, and eventually we'll also get an interface towards what algorithms are, and we'll also learn how to create algorithms. This is what we'll be doing in the next week's class. Okay. So I guess there is no more questions. So that means we are done for the day. So people revise everything that we have discussed so far and whatever you have discussed with Rohit sir as well. And let's meet up again in next weekend's class. Okay. Till then, have a great week, guys. Ahead. Bye bye, everyone. Good night. Homework is to revise everything. Okay. That's the homework. You revise everything. Very, very important. Revision is very important. Okay. Bye bye.